Welcome to video number 7 of the panel series, in which now we are working with the top bar icons. In this video, we're going to present only two of them, 16 and 17, that correspond to functions and units. There's a lot of material to be covered here, so that's why we only present these two particular icons. To get started, we're going to open up this worksheet and let's talk about the functions icon. There's a lot of information in here, and I'm just going to go over it over here. The functions icon is this one, the FX. If you click on it, it will open up this entry form where you're going to have here categories of functions, starting with all the functions available, matrix and vectors, complex numbers, trigonometric functions, hyperbolic functions, programming, strings, and functions that apply to files. I'm going to use this as an illustration, a hyperbolic function. I have a total of 10 hyperbolic functions, as indicated here, and they are in order, in alphabetical order. The arc-cosine, hyperbolic, the arc-tangent, and so on. Suppose I want to deal with the cosh. In the example, it tells me what I need to do to call the function, and then what the function represents and how to use it. So I could click over here. Well, I'm going to have to cancel here and click. I need to have a click point where you're going to introduce the function and go here and go to hyperbolic, cosh, insert, and enter a number like 3.0. Wait, it just went up that way. 3.5, and then the equal sign, and I give it the hyperbolic cosine. I'm going to show you another example of functions here, and that would be the complex number functions. X, Y to pole, that means convert from Cartesian XY to polar coordinates. The call of the function is XY to pole. The arguments 1 and argument 2 convert the rectangular coordinates. It doesn't give you a lot of information in here on how exactly is the function. You got to figure it out from what you know. And since we're converting from XY to polar, I would say we put the XY functions of the XY values in here and equal. And so this gives me a result that uses this symbol. And the first one represents the magnitude of the vector from 0 to 3, 4, and this the angle and radians of that vector. Let's look at another function there. In the complex number functions, well, we already did that. Hyperbolic function, we have that trigonometric, let's say. Arctangent 2. Arctangent 2 uses two complex numbers and give you the inverse tangent. Actually, what this actually means is that the y value of a point and the x value of a point will be given. And so if you do insert here and say 3, 4 equal, it gives you the arctangent of 3 over 4. You could have used the other arctangent, which is the same name, but 3 over 4. The main reason for having these two is in case you have a 0 in the denominator, because when you have a 0 in the denominator, then you have this, which is equivalent to, I'm going to use something here, I'm going to click in here and type quote DEG. That converts radians to degrees, that's 90 degrees. The arctangent of 90 degrees is infinity, and so a 10-2 allows you to calculate those values without getting an error.